Okay, so today we're jumping into chapter 3, and we're going to talk about quadratic functions. And quadratic functions are the x-squared equations. So we have these two forms of a quadratic function. The first one is the standard form, which is this ax squared plus bx plus c stuff. Okay, so this is our standard form of the equation, the ax squared plus bx plus c, where a is a number, b is a number, and c is just a number. Okay, so always remember when you see those letters a, b, and c, they try to stay away from those as variables, and they use them as your constants or your numbers. So it talks about your parabola opening up or down, and if that leading number, which is your a, if it is greater than 0, then that means it opens. Well, it's got it written backwards. If it is less than 0, if this number is less than 0, or if this number is negative, it's going to open down. So this one opens down, which we kind of already know that. We already know that because we know that it's reflected over the x-axis when that term is negative. So we're going to call that now opening down. When it's been kind of reflected, they now refer to that as opening down. But if this number in the front is positive, then it's not reflected, and this is going to open up. Opening up. So they now call that opening down and opening up according to that leading coefficient being positive or negative, which we remember as being where it's reflected over the x-axis. Okay, so opening up and opening down. Okay, so that's just kind of the basis of your standard form of your parabola or your quadratic equation. Now the next form is the vertex form. Now this is a pretty big guy here, okay? The vertex form is really, we work with the vertex form a lot. And it's called the vertex form because from the equation, we can pull the vertex from the actual equation. So this f of x equaling a times x minus h squared plus k, this is referred to as the vertex form of your quadratic function. So here's a real simple example, -1 x minus 2 squared minus 5. And so if we look at this, the number with x and the number on the end are going to tell me my vertex. And so they refer to this as hk. So your vertex is referred to as hk, where the h is a 2 and the k is a -5 in this example. So in this example, your h is 2 and your k is -5. So your vertex in this example is 2, -5. So the tricky thing about that is it's going to be opposite of the sign you think it should be when it's in those parentheses with x. Okay, so that's kind of the tricky part. And the reason it's like that is because the original form has a subtraction, which takes that subtraction and leaves the 2 to be h. So they've duplicated the subtraction, leaving the 2 as the h and not the -2. So don't confuse that. And in fact, at this point, you know that this means you went right 2 from the origin, so that would be a positive 2. So if you just need to go back to your transformations to get that sign on your vertex correct, then do so. So in this example, our vertex is 2, -5, and the negative in the very front, that negative, whether it's a -1 or a -3 or whatever it is, that tells us now that it opens down. And we remember from transformations, that's where you flipped it over the x-axis, which, yes, then made it open down. So if I wanted to do a rough draft here, or graph of this, my vertex is 2, -5, which would be way down here. And then it's supposed to open down, so it looks something like this. Okay, so that would be it. 2, -5, and it is opening down. Now, every parabola has the mirror image across its line intersecting down the middle of it. So in other words, if I draw a line through the vertex, cutting the parabola in half, the parabola is a mirror image over that line. So that line they call the axis of symmetry. The axis of symmetry is that line that the parabola would be a mirror image over. Now that line is going to be a vertical line, and if it's a vertical line, the equation of the axis of symmetry, because it's going to be a vertical line, its equation will be an x equals a number. And since the vertex is the point 2, -5, the axis of symmetry is x equaling 2. So the name of the vertical line for which the parabola is a mirror image is x equaling 2. Okay, so your axis of symmetry will be x equaling a number, and it will equal the x value of the vertex of your parabola. Okay, so this form of the equation, the vertex form of the equation, is really handy because we can pull the vertex from it and we can get the axis of symmetry from it. Okay, so that form we use, and we use heavily. The vertex form is just really, really a friendly form of a quadratic equation. Okay, so now let's take a look at some examples. Let's talk about graphing this, and instead of using the method we already are comfortable with, which is transformations, let's try to use the HK and the axis of symmetry and opening up and down and stuff. Okay, so the first thing it says is identify the vertex, and so usually we just put a V in front of an ordered pair. So the vertex is HK, and so it's going to be a +3, -9. So if you remember from transformations, that meant right 3 and down 9. So your vertex is 3, -9. So we're over here at 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. There's the vertex. 3, -9. This is in front of this equation. You would say right here in the front, you could say that there's an assumed +1 sitting there. Since it's a positive value, we can say that this is going to open up. In other words, it's never been reflected over the x-axis. It's going to open up. So now we know sort of what it looks like, but to get greater details, they're going to ask you what are the x and y intercepts. Okay, so let's think about this. The x-intercepts, which just so you know, they're going to start calling these the zeros of the function. X-intercepts are going to be called zeros of your function. X-intercepts occur at the points where the y value is 0. So taking my equation, which if I wanted to rewrite it would be y equaling x minus 3 squared minus 9, and replacing the y value with 0, this would say 0 equals x minus 3 squared minus 9. Now to solve it, I need to add 9 to each side, so then it becomes 9 equaling x minus 3 squared. Anybody know how I get the x out of this mess? What do I need to do? Take the square root. So this really, now remember, when you create that square root, you have to remember to put the plus minus in front of it. So you're taking the square root of 9. So this is a positive -3 equaling x minus 3. So in other words, x minus 3 could be positive 3 or x minus 3 could be -3. So we kind of want to make this two equations. So x minus 3 can be the positive 3 or the -3. So if I add 3 to each side, one value is 6 and the other is 0. So I have two x-intercepts. One is the point 0, one is the point 6, 0, and the other is the origin. So going to my graph, I'm going through the origin on my graph paper, and I'm going through the point 6, 0, which will now give me a really good understanding of kind of how wide this parabola is. It's going to look something like this. Okay, that's a really good sketch of your parabola. Now the other thing this one does ask is it also asks for the y-intercept. Well, the y-intercept is the point where the x value is 0. So going back to my equation, I put y equaling 0 minus 3 squared minus 9. which is y equaling a negative 3 squared minus 9, which is y equaling 9 minus 9, which is a y value of 0. So your y-intercept is the origin, which from our graph already we can see that that is where it crosses the y-axis. In a lot of cases, of course, they would differ, but in this case they turn out to be the same. So we have our x-intercepts, we have our y-intercept. Here's our y-intercept. And down here lower on the page, these are our two x-intercepts. Okay. And so the last question it says is, what is the axis of symmetry? So this is where you draw the vertical line through the vertex of your parabola, and then you name that vertical line. So when you name the vertical line, a vertical line always has an x equals as its equation. So what is the equation of that dashed vertical line? X equals 3. Okay, it's x equaling 3. So my axis of symmetry is an equation of a vertical line, and in this case it's x equals 3. X equals the x value of the vertex of the parabola. So we've got a lot of information here. It opens up. It has x-intercepts of 6, 0, and 0, 0. It has a y-intercept of the origin. It has an axis of symmetry. Okay, a lot of information we have because that function is written in the vertex form. Okay, all because that function is written in the vertex form, we have a lot of information on it. All right, so let me see what we have now. We have another one. Okay, here's another one with the same questions. I hope I gave myself enough room here to do it all. Okay, so the first thing they want is the vertex, and so the vertex is the HK. So the vertex on this one is going to be 2, because it's right 2. It's going to be flipped and then down 1. So it's right 2, down 1. My vertex HK is positive 2, negative 1, right here. There's the vertex. Now, this negative in the front, what does that mean? Open up or down? Opens down, because really that means a reflection over the x-axis. Okay, opens down. So then they want to know the x and y intercepts. So, okay, remember, this is a good time to get this in your head. The x-intercept is going to be renamed the zeros of your function. The textbook, the talk, everything, they start calling them zeros of the function. So if I take it out of function notation and just write it as an equation, and I know that my x-intercepts occur where my y value is 0, and there's probably going to be 2 of them. I don't know, there'll be times where there's none. Let's see what happens if I let the y value be 0. So 0 would be negative times your x minus 2 squared minus 1. If we add 1 to each side, okay, and here's the step you don't want to miss, so I'm going to do it in a color or something wild, orange, whatever. This negative 1 in the front, I'm going to divide it off. And when I do that, it's going to cause this to say negative 1 equaling x minus 2 squared. Okay, according to my last example, what do I do at this point to get the x out of the perfect square situation? Take the square root. Okay, what's getting ready to happen now? I cannot take the square root of negative number, right? Does not exist. So that means no x-intercepts. That actually makes perfect sense, because look at your graph. If this thing is opening down, which we already said that, it's never crossing the x-axis. If this thing is going to open down, it's not going to cross the x-axis. There are going to be no x-intercepts. Okay, so that works. That's pretty logical. Okay, so let's stay on track now. That didn't work. Let's go with the y-intercept. There can only be one of these at most, right? Okay, so on the y-intercept, this is the point where the x value is 0. So using this equation, y is equal to the negative 0 minus 2 squared minus 1. So y is equal to the negative of a negative 2 squared y is equal to the negative. Well, a negative 2 squared is positive 4, so the negative is going to hit that positive 4. Be really careful with your parentheses and your negatives all over the place here. And so a negative 4 minus 1 is a negative 5. So my y-intercept is the point 0, negative 5. 1, 2, 3, 4, 5 right here. Okay, so that's all I have is my y-intercept. I know this thing opens down. I know my vertex. And I know that this is my axis of symmetry. Whoops, I missed it. It's kind of hard to get sometimes this pin right where I need it to be. Okay, here is, I know I have an axis of symmetry through that vertex. So if this side is coming like that, through the point 0, negative 5, I can very easily put another point. So this is like 2 to the left, and this is going to be 2 to the right if they're going to be a mirror image. So I can put another point on my line so I can get a nice sketch of my graph. By that mirror image to the y-intercept, I can put another point and therefore get a very good sketch of the graph, knowing that it also opens down. So we said this vertex is the point 2, negative 1. So what is the equation of this axis of symmetry? X equals 2. It's an equation of a vertical line. So your axis of symmetry is x equals 2. Okay? So you have your vertex. You have it opens down. We have our y-intercept. We have no x-intercepts. We have an axis of symmetry. A lot of information because this equation of this quadratic function is in vertex form. Okay, some really good stuff. Okay, so since we like vertex form so much because we can get such details about the function in that form, now we run into the situation where part B, this thing called complete the square. Complete the square to write this function vertex form. Okay, oh man, what is this? This is standard form. And in standard form, I can tell you if it opens up or down, but I can't look at an equation like that and tell you what the vertex is, which in turn gives me the axis of symmetry and all kinds of stuff. So I have to have a method of converting this equation in standard form to vertex form. And the method is called complete the square. So completing the square is the way that we take an equation that's in standard form and turn it into vertex form so I can get a lot of information from it. Okay, so this is an interesting process. If you've never done this, you're going to find this to be very strange. Okay, so the first thing I'm going to do is take my equation, and it is not in vertex form. I have no clue what the vertex is. So I'm going to do this method called completing the square. Okay, the first way you start with completing the square is you move the constant to the left side of your equation. Okay, move the constant to the left side of the equation. So only your x terms are on the right side of this equation. Okay, so here's where it gets interesting. You take a look at this coefficient of x, okay, this number right here, and we're going to do some strange things to that number. We're going to take that number and we're going to take half of it. So I'm going to take half of that number. So I'm going to take negative 6 and I'm going to take half of it. Half of that number is negative 3. Then I take that number and I square it. Negative 3 squared. 9. And I get a new number, 9. That's kind of like a magic number, okay? So this is like the process. Take half of the middle number and square it. Okay, that 9 I'm going to add to each side of this equation. So I'm going to add 9 here, and I'm going to add 9 here. I must do the same thing to each side of the equation, or the equation doesn't have an equal sign. It's not valid in the middle anymore. Okay, so now, oddly enough, what this does, which is the whole goal of the whole process, is the right side becomes x plus or x minus something perfectly squared. When I, quote, complete the square, I create three terms which will factor into something perfectly squared, and that something is going to be x minus 3. So in other words, this number in parentheses before you square it, that's the number that's going to go with the x. So it's x minus 3 perfectly squared. Now on the left side, I just have to put these numbers together. A negative 7 plus 9 is a plus 2. And then if I want to say y equals, I subtract 2 from each side of this equation, and it's x minus 3 perfectly squared minus 2. Now, the equation which was in standard form is now in vertex form. I am now in vertex form. So the way it works is you get the x's on the right, you take the middle term, take half of it, and then square it. Add that number to each side, then you factor into a perfect square, then move the constant back over. So now that being done, okay, now that I'm in vertex form, my vertex is, that's to the right 3 and down 2. So it is 3, negative 2. There it is. So there's my vertex, and it's going to ask me the y-intercepts. Okay, the y-intercepts are a little bit easier than the x-intercept. So if I want the y-intercept, it's not asking me quite so many things. The y-intercept occurs where the x value is 0. So this will be y equaling 0 minus 3 squared minus 2, which is just a negative 3 squared minus 2, which is a 9 minus 2, which is a 7. So my y-intercept is 0, 7. Here we go. Where in the world? I'm off the screen at 0, 7. I'm way up here off my graph. Okay, so is my vertex opening up or down? It's up. And I can look at both forms for this, because in standard form it was a positive in the front, and in vertex form it's a positive in the front. So this thing opens up. So it's coming up through here, through that 0, 7, and that's not supposed to be a point at the vertex. Don't make a V, okay? Mine tends to want to look like a V. Don't make a V down there. And then I know that this is going to be the line that I'm supposed to have a mirror image through. So if I'm to the left, what would this be? 1, 2, 3. I'd be to the right. 1, 2, 3. And this would kind of give me a little better guideline to get the sketch of my parabola looking pretty good. Opens up. I know my vertex. I know my y-intercept. I have this sucker in vertex form. And what is my axis of symmetry? Hold on, it's an equation of a line. X equals 3. It's an equation of a vertical line. Okay, so that completing the square business, we're going to do a lot of this. I know it's kind of strange, and so we're going to practice it quite a bit. All right, let's go down and take a look at another one. Okay, complete the square. So this is in standard form. It's given to me in standard form. I know it opens up because it's starting off with a positive number. That's all I know from that standard form is it opens up. Okay, and I need to put it in vertex form. Well, the first thing you don't like is this 2 in the front. You cannot complete the square unless it starts with a 1. Your leading coefficient has to be 1 to complete the square on something. You divide everything by 2. Here, and here, and here, and here. Okay, everything divided by 2. And that looks like that's going to be awful. It's really not. Okay, that's not that bad. It's not going to be bad. So now we have x squared plus 10x plus 21. And just leave that y over 2. Don't touch it, leave it alone. Just keep writing y over 2 on the left side. Okay, so remember when you complete the square, you have to get everything away so you only have x's on the right side. So now I have to subtract 21. So I've got y over 2 minus 21 equaling x squared plus 10x. Okay, so here comes that weird process. You take a look at that number in the middle, that coefficient of x right here in the middle, and it's a positive 10. You take a look at that number and you do this weird process. You take 10 and you divide it by 2, so you take half of the number, which is 5. Then you take that number and you square it, which gives you a 25. Take half of the middle coefficient, square it. Okay, so now that 25 is the number that we add to each side of this equation. It has to be added to both sides or the equal sign is no longer valid. The reason we do that, and the only reason we do that, is because the right side now factors into something perfectly squared, which gives me the x value of the vertex of the parabola. And the number that goes in here is the number that you squared. So it's a positive 5. So right now, even with this mess on this piece of paper, I can tell you the vertex, the x value of the vertex is a negative 5, which means my axis of symmetry is x equaling negative 5. That's a lot of information with that little 5 right there. Now the right side's kind of a mess, but this is y over 2, and a negative 21 plus 25 is plus 4. Now I'm going to move the 4 over, so it says y over 2 equals x plus 5 squared minus 4 when I subtract 4 from each side. And then to get that y halves kind of mess to go away, then I come in here and I got a mess. I come in here and I multiply this times 2, this times 2, and this times 2. So when I do that, I now have y equaling 2 times x plus 5 squared minus 8. It is now in vertex form.
Where does the 25 on the next side go?
When you factor, okay.
Because you said add 25 to both sides.
Right. I got it right here. It's in this little balloon thing. That's where it came from. But how does it disappear? Okay, if you take x plus 5 squared, right? That's x plus 5 times x plus 5, which is x squared plus 5x plus 5x plus 25, which is x squared plus 10x plus 25. So now, x plus 5 perfectly squared is x squared plus 10x plus 25. Y'all see what I'm talking about here? These are equal to each other. And I just took x squared plus 10x plus 25 and factored it into x plus 5 times x plus 5.
That makes sense.
Okay, so it's a factoring. You're factoring it. And we're just kind of doing all this little tricky shortcut stuff, but you're factoring it. Okay, so now if I want to try to graph it, what is my vertex now? My vertex is negative 5, negative 8. So negative 5, negative 8 is down here. And I've got to erase this stuff here this mess I just made because it's going to be in my way. But hopefully that kind of clarified, you could say kind of the magic I was working there, I guess, or what looked like magic. Okay, so there's my vertex. Is this thing opening up or down? Opens up, because this is a positive 2, and it was a positive 2 even in the standard form, so that makes it open up. Okay, so it opens up. So if it's opening up, and they're going to probably ask me my y-intercept. They are going to ask my y-intercept. So my y-intercept is the point where the x value is 0. I hope I have enough room here. Okay, and I haven't, boy, there's 2 places you can go, but we've always gone to the vertex form. Okay, so I have y equaling 2 times x plus 5 squared minus 8. So if my x value is 0, this is 0 plus 5 squared minus 8. So this is 2 times, lovely, 5 squared, which is 25. This is a huge number. 50 minus 8. This is 42. So my y-intercept is 0, 42. This is going to be way off my graph. This means this is a very narrow graph. Means it's rising very quickly. It is so far off my graph, way up here, somewhere way far up here, right? And so we're just going to do a rough sketch. We're going to agree that my graph is very narrow, and somewhere way up there it's going through the point 0, 42. But the big question now is, what is the axis of symmetry? X equals -5. Very good. It's an equation of a vertical line. So be careful. Don't get into that bad habit of saying it's -5. It is an equation of a line, an equation of a vertical line. So it's x equaling -5. All right. So really the big stuff here is learning to complete the square still. Y'all seem to have the rest of it quite smoothly already, which is wonderful. It's that completing the square business that's quite interesting. Okay, so here's one we're very fortunate because it has a leading coefficient that's 1. So this is nice. Okay, this is a good one. This is a lot easier one. So we need to complete the square. It's in standard form. We want it in vertex form. So currently it says y equals x squared plus 2x minus 5. So I don't have to worry about dividing by a number because my leading coefficient is 1. So get everything away from the x's, meaning add 5 to each side of this equation. Okay, here comes the pattern. Half of the middle term, square it. Okay, here comes the pattern. Half of the middle term, find the middle term, half of that number, square it. Okay, so I'm going to take half of 2. I'm going to take 2 halves, which is 1, and I'm going to square that 1, which is again 1. Okay, so that means I add 1 to each side of this equation. So that number, that cool little trick to come up with that number, now gives me the ability to factor this right-hand side into x plus something or x minus something perfectly squared. What goes with this x?
X plus 1.
Plus 1. This number that's being squared, which is a positive 1, is what goes in there. Okay, so the left side is just y plus 6. So then when I subtract 6 off of each side, this becomes x plus 1 perfectly squared minus 6. So this one was easier than the last one because they were kind in giving me a leading coefficient of 1. Now that it is in truly vertex form, it started in standard. We switched it to vertex because vertex gives me so much information. And now that I'm in vertex form, my vertex is what? -1, -6. Very good. Okay, there's my vertex. Then it's going to, this one says x and y intercepts, but I think I'm just going to do the y-intercept because of space, really. Okay, so my y-intercept is the point where the x value is 0. So I get y equaling 0 plus 1 squared minus 6. Y equaling 1 squared minus 6. Y equaling 1 minus 6, which is a -5. So my y-intercept, I got a vertex, and I have a y-intercept. Is this going to open up or open down? It's going to open up, right? Okay, it opens up because this is a positive in front of my x squared. Okay, that's a positive 1 that we don't ever write. but it's positive. And because of that, it's going to open up. Okay, let's take a look at it. So -1, -6. I'm going to have to get bigger little grids on here. There's my vertex. It opens up. It goes to the point 0, -5. Okay. So what is the mirror image of 0, -5 on the other side? Well, let's put my axis of symmetry. Let's just sketch my axis. So if I'm 1 to the right, now I'm going to be 1 to the left of it. So here's my other point, right? Just by using like more geography, I guess. More mirror image thing. So here's your point 0, -5, and the mirror image gives you what point over here now? -2, -5, right? Let me write that a little bigger. Your mirror image point, we didn't go to the equation or anything, we just mirror imaged, and when we did, it's going to be -2, -5. And then your vertex is -1, -6. So this will give me a pretty nice graph. And what is my axis of symmetry? There, now we're getting it. X equals, and it's a -1. Are y'all starting to feel a little better about it? You probably feel good about everything but the completing the square, right? That completing the square is like, whoa, that's kind of weird. Okay, so here's another completing the square. Get down here. Yeah, I purposely did not do that because of space. Okay. I purposely did not do that one. Okay, so we're just going to do the y-intercept. Okay, so here we go. This one, I can tell you right now, is a little more difficult. Why do you think I'm saying that? There you go. This guy right here, black it out. How's that? I just blacked it out. Okay. Get rid of it. That one, right? That lovely 2 right there wants to make things difficult. All right, so here we go. Y equals 2x squared plus x minus 6. Oh, that 2 is bad. It's really bad in this case. Okay, so I'm going to divide everything, oh my, by 2. Y'all can see already this does not look very enjoyable. Okay, so this is y divided by 2 equaling x squared plus, really that's a 1/2 x minus 3. Or x halves, which way you want to say it. Now I'm supposed to move the 3 over. So this is y halves plus 3 equaling x squared plus 1/2 x. And I'm kind of leaving a little space on the left side of the equal sign because I'm already projecting that I know I'm going to put another number in there. Okay, so I'm going to leave a little space over there because I've got to put a number in there. Okay, so here we go. We're supposed to take half of some number. We're supposed to be taking half of the coefficient of x, right? What in the world is half of a half? Oh, there you go. Okay, so we're taking half of a half, which is a fourth. Now we've got to square the 1/4 and get 1/16. Okay, so that 1/16 is what I add to each side of this equation. And you don't worry about that 1/16, okay? Just put it on there. Because you know right now that you don't have to work real hard to factor this because this is kind of a neat little, almost magical thing. What is the number that's going to go with this x? What? The one before you square it? 1/4. Okay? The one before you square it. Now the left side does not look fun. Okay, so what's going on over here now? So this is y halves 3 plus 1/16. You can look at this at 2 ways. This is 3 and a 16th, which is 49/16. So I'm just going to put on here, and y'all know how to do that on your calculator, so don't panic about that. You know how to do that on your calculator, so don't get all upset and think, I'm never going to do this now. Okay, so now we're sitting good. I move the 49/16 to the other side, so I have y halves equaling x plus 1/4 squared plus, right, let's put a minus sign in front of it. That looks like really awful. But oh well, because you're almost done, so you don't really have to fool with it anymore. It's just out there. It's just on the end. The only thing I have left to do now is multiply everything times 2. Here, and here, and here. So then it says y equals 2 times x plus 1/4. Don't forget to square that. Minus, what is this? 49 over what? 2 and 16. There you go. There it is. There it is. Step by step, okay? One step at a time. No one jumps from the top to the bottom. You go through the process to get to that result. Okay, through the process. So the vertex is -1/4, -49/8. No matter how ugly it is, we can still graph it. Oh my. Lovely. What in the world is 49/8? What did we just say that was? That's like 8 goes into 49 how many times? 6 times? So it's 6 1/8, right? So this in your head, think about 6. -6 1/8. Okay, so the vertex is like tiny little -1/4, and down here -6 1/8, like here, something like right there. Something like that. Okay, what is your axis of symmetry? This is easy. It's x equals what? A -1/4. So it's man, it's like right here, guys. It's just like almost touching your y-axis, like that. What in the world is the y-intercept? That might not be joyous. Ugh. Okay, oh my gosh. Okay, the y-intercept is where the x value is 0. Y equaling 2 times. Ooh, I can cheat. I have an idea. Anybody have any ideas? Do I have to use the vertex form of the equation to get the y-intercept?
No.
Isn't the standard form of the equation the same equation? They're the same equation, right? They're just written differently?
Mm-hmm.
So if I want to make this a little easier, maybe I should go up to the standard form to get the y-intercept. I can do that. So if the x value is 0, oh, it's just -6. Okay, so if you want to kind of avoid all those fractions, you can go back up to the standard form. That probably would be easier. So 0, -6 is like right here. This is really hard. Looks like dice, like little dots on a dice. Just kind of, we're just gonna like go for it and call it good. Now, something I've not been squaring off is they might very specifically say, what is the vertex form of the equation? And this is it. They might ask you for that. In fact, they probably will. So I probably should have been squaring off the vertex form of this quadratic function, and I've not been doing that. Okay, so do I have another example down here? No, one more. Let's see if we have time to do this one. Here we go. Why is this one not very attractive? Oh, that lovely -3 makes it not fun at all. Ugh. Okay, so we just have to kind of dig deep and be patient. Okay, so we just have to be really patient, have to be very careful. So the first thing I do is divide everything by -3. Oh, it looks awful. Okay, so it's y divided by -3 equaling now x squared minus 4x plus 8/3. Then I move the 8/3 over. So this becomes y over -3 minus 8/3, leave a little space, x squared minus 4x. Some of it's not too bad. Okay, here comes the magic. You're going to take half of -4, which is -2, and square it and come back to a +4. Okay, and that scratch work you need to have pretty close by because you're going to pull two numbers off of it. One of them is that +4 you're going to add to each side of this equation. And the other is the -2, which is going to give you that ability to factor. So this is an x squared, and what goes with that x in those parentheses when it's factored? The -2, okay, the -2. Oh, my x value of my vertex is going to be 2. My axis of symmetry is x equaling 2. Got all that? Okay. The left side is not really very nice over here. This is y over -3, and -8/3 plus 4 is a -8/3 plus 12/3, which is, what I just say, -8/3 plus 12/3 is 4/3. +4/3. And you can do that on your calculator. Then whenever I subtract 4/3 from each side, this becomes x minus 2 squared minus 4/3. And this time you're going to divide everything by, or you're going to multiply everything by -3. Not just 3, but a -3. So we're going to get y equaling a -3 times x minus 2 squared plus what? The 3's are going to cancel, and what number's out here on the end? 4. There you go. There came the 4. I must have been ahead of you. There it is. Hey, that looks pretty nice. The process was not very pleasant, but that looks pretty good. So what's my vertex? 2, 4. What is my axis of symmetry? It's an equation. X equals 2. Is this thing going to open up or down? Opens down. There's that negative in the front, right? And the y-intercept. Ooh, this is getting ready to be easy, right? You can do this one in your head, really. If you go back to y equaling a -3x squared, if you go back to the standard form, what is your y-intercept going to be? -8, right? Looking good. Okay, 2, 4 up here. Y-intercept is 0, negative. Yeah, it's going to be very narrow, right? Way down here. Axis of symmetry right here. Coming down like that. And then if I go, this is 2 to the mirror, 2 back away from the mirror, so I get another point over here, which would be what? 4. If this is 0, -8, my mirror image on the other side of the axis of symmetry would be what? 4, -8. Careful and don't make that a point up there at the vertex. That's not a point. It's supposed to be kind of a U shape. And there's your graph. Okay, so that's about all we have time to work on today. We'll have to come back and finish this.